Okay, so we're going to be looking at the Algebra 2A Unit 4 tutorial, multiplying and dividing complex numbers. So the important part here when we're working with imaginary numbers, so when you see I, is that I is equal to the square root of -1, which means that I squared equals -1. And so we're pretty much going to be treating I like a variable, just like X, every time we multiply and divide. But at the end, when you get your answer, all we're going to do is if there's any x squareds, we're going to just change that to -1. And so it's pretty simple. So here, if we're going to be multiplying 6i times 3 plus 2i, this is just distributing. We're going to take 6i and multiply it to 3 and multiply it to the 2i. And then, like I said just a second ago, if there's any I squares at the end, we're going to change that to -1. So here, if we multiply 6 times 3, we get 18, but don't forget the I. So 18i. And then 6i plus 2i, 6 times 2 is 12. I times I is I squared. So this looks great so far, but that I squared changes to a -1. So that's what they're showing you here. And so we have 18i plus 12 times -1, which gives us 18i minus 12, right? Positive 12 times -1 is -12. And then you want to rearrange this so that the real number, the one without the I, is in front, but keeping the signs. So our answer is -12 plus 18i. So the only thing that's different, if these were x's, you do the same thing, but as soon as you get that I squared, it changes to -1. Okay, so now we're going to use FOIL. It's going to be the same thing though. So first, outer, inner, last. So 1 times 5 is 5, 1 times 7i is positive 7i, -4i times 5 is -20i, -4i times a positive 7, that's -28, and I times I is I squared. So everything is good. We're going to combine like terms. So we're going to combine the i's as if they were x's. So we get -13i. And then whenever you see I squared, you change it to -1. So that goes in here. And so we get 5 minus 13i plus 28. And they went ahead and added the 5 plus the 28 because those are like terms now since they're just real numbers. And we get 33 minus 13i. Okay, so then let's go ahead and do this one together. So this is just going to be FOIL 3 plus 7i times 1 minus I. So 3 times 1 is 3. 3 times -I is -3i. 7i times 1 is 7i. 7i times -I is -7i squared. So we know nothing can be combined with the 3 yet. -3i plus 7 is plus 4i. And then we have -7. This I squared is really -1. So we got -7 times -1. So we get 3 plus 4i plus 7. And now the 3 and the 7 are like terms. So we get 10 plus 4i, which is right there. All right. Okay, so now dividing, all that you're going to do whenever you have a division problem is you're going to multiply the top and the bottom by the conjugate of the denominator. The conjugate of the denominator just means you change that sign between the two numbers, or you change the sign of I. So if it's positive, it'll change to negative. If it's negative, it'll change to positive. So what they're doing here is the conjugate of 2 minus I is 2 plus I. And so that goes on the top and the bottom, and then you just do FOIL like we did a second ago. So 4 times 2 is 8, 4 times I is 4i, 3i times 2 is 6i, 3i times I is 3i squared. And then on the bottom, the cool thing that will happen when you have a conjugate on the bottom is that a lot of things cancel out. So 2 times 2 is 4, 2 times I is 2i, -I times 2 is -2i, so those will cancel, and -I times I is -I squared. And so what will happen is in this denominator, since they did several steps at once, the 2i and the -2i cancel, so we get 4 minus I squared, but remember I squared is a -1, so it's really 4 minus -1, which is 4 plus 1, which is 5, and that's how they get the denominator. And here they did a couple steps in one also. 4i plus 6i is 10i, and then 3i squared, remember the I squared turns into -1, so 3 times -1 is -3. So now we have 8 plus 10i minus 3. 8 minus 3 is 5, plus 10i. And so now we have 5 plus 10i over 5, which is a correct answer, but they want you to reduce it, and we can reduce all of these by 5. If you can only reduce some of the top parts, you can't actually do it. But since we can reduce both of these by the denominator, then we're going to cancel. So we can reduce them all by 5 to get 1 plus 2i, and 1 would just be on the bottom here, and you don't need to write it. All right. Okay, so let's do a couple examples. Okay, 3 minus 2i squared minus 3 times I minus 2 plus 5. So we're going to do the 3 minus 2i squared first. Now this is important because a lot of people just square the things inside, but that's not how we do this. Remember that 3 minus 2i squared is 3 minus 2i times 3 minus 2i. So you always have to expand it when we're squaring it like that. So now we just do FOIL. 3 times 3 is 9. 3 times negative 2i is negative 6i. Negative 2i times 3 is negative 6i again. Negative 2i times negative 2i is positive, 4i squared. And so now we do 9 minus 12i after combining these, plus 4 times, remember I squared is negative 1. So now we have 9 minus 12i minus 4. 9 minus 4 is 5 minus 12i. So that's that first section right here. And so then for this one, we're just going to distribute the 3. So I'm going to write it here. Negative 3 times I minus 2. Negative 3 times I is negative 3i. Negative 3 times negative 2 is positive 6. So this is what comes down here, minus 3i plus 6. And then we have our plus 5 from right there. And then we just combine like terms. So 5 plus 6 is 11, plus 5 is 16. Negative 12i minus 3i is negative 15i. And that one is done. Okay. Now this one here, they didn't really tell you to do this, but what we're going to do is change those negative radicals into something with I in them. So if we have square root of negative 49, we know we can take the I out so that now it's just square root of 49. Okay, taking the negative out brings an I out in front, but we also, in this case, know that the square root of 49 is 7. So our answer here would be 7i. Same when we do negative 4. We can take out an I and have square root of 4. Square root of 4 is 2, though, so that becomes 2i. So this is really 2 minus 7i times negative 3 plus 2i, and then you would just do FOIL for that. Okay, so then this one has a couple steps that we're going to do, including the dividing. But first we're going to take the square root of negative 9 and turn that into I square root 9, turn that into 3i. So it's really 3 plus I over 1 minus 3i. And so we're going to multiply the top and the bottom by the conjugate of this. And remember, the conjugate just means you change that sign, so it's going to be 1 plus 3i. 1 plus 3i. The top, you just do FOIL. The bottom, what's going to happen when you do FOIL, 1 minus 3i times 1 plus 3i, is we're going to get a lot of things canceling. 1 times 1 is 1. 1 times 3i is positive 3i. Negative 3i times 1 is negative 3i. Negative 3i times positive 3i is negative 9i squared. Those cancel. We get 1 minus 9, but this becomes a negative 1. So we get 1 plus 9, and that gives us 10. So 10 will be on our denominator, and then whatever you get on the top here will be your numerator. Okay, this one is pretty much like the first question. We're not going to go over that. Let's go ahead and look at this together. So basically what we're going to do here first is we're going to multiply the bottom together using FOIL, 3 plus 2i, and then once we have our denominator, then we're going to multiply by the conjugate of that. So 3 plus 2i times 3 plus 2i. We get 9 plus 6i plus 6i plus 4i squared. So we get 9 plus 12i plus 4 times negative 1. That's 9 plus 12i minus 4, so that's 5 plus 12i here. So that was just doing FOIL. So if I have 5 plus 12i here, and you're going to just multiply the top, get whatever you get, and then we're going to multiply the top and the bottom by 5 minus 12i. 5 minus 12i, because that's the conjugate. All right. Okay, and so then the rest of these are just some practice, which hopefully will be pretty easy now.